All right, without any more waffling, I think I'll introduce David, VK3RU, and Phill VK3VC, who are going to enlighten us on the art of recrafting Codan radios.
Thanks, Martin, and greetings all. So I'd like to introduce a long-time friend, Phill VK3VC. We go back a very long way, and I suspect that when we met I was riding a push bike. So, and what's more, Phill went to Geordie Tech and I went to Ashwood High, and the dotted line down the middle of Vannon Drive was the delineation point. So there we go. I'm going to cheat. Do you want to do that? You can do the push button.
I can do that. Yep.
So, context, we both trained as techos back in the 60s and early 70s, but Phill stayed with it. He went off to Willis Island and then joined ACI Electronics and other things, and then finished up running his own business with UHF Comms. Meanwhile, I bailed out and got into property and construction, so, but I did retain an interest in radio. So since relocating from suburban Melbourne, Phill became a bit of a Barrett guru with the local boys up there. They discovered that he knows a bit about Barrett, so they brought over their antennas full of water and said, here, can you fix this? So he let the water out, and away they went. So, and I'd have to say, what's the difference between a Codan and a Barrett? Both iconic brands that were made in Australia, or still made in Australia, and both companies have gone on from strength to strength. So let's just have a bit of a look at some of this. As you would probably know, I've had a fair bit of experience with deceased estates of late, and in one lot there was some Codan radios and old lunch boxes, whatever they're called, 6925s or something.
6924s, yeah.
Oh, it wasn't far out, was I?
Yeah.
And so I did a few repairs and sold them off to collectors. And in amongst it was a Kestrel. Now I had to ring Phill with that one because he knew a bit more about Kestrels than I'll ever know. So that was sort of, they were sold at, the Kestrel was sold at a car boot sale to a guy, in fact Glenn, 3YY, who, when I said, what are you going to do with it? He said, oh, I'm going to play around with DDS. So it's a rock box, the same as these Codans. And that's what he planned to do. So I had a mate of mine who lives out in Narre Warren say, listen, there's an auction out the other side of Sunbury and there's a whole lot of radios there that you might be interested in. So I had a look online and there was a big pile of Codans. And of course the ones that I saw are the ones over on the left-hand side. And I thought, oh, they're like the lunch boxes. I'll grab a few of them and have a bit of a play. So that was what it was. So I bid online and bought the lot. So Shirley and I went out there to collect and we realised that, all right, okay, some of those would be all right, but I don't know about these ones with a big Jones-like plug on the front. So anyway, loaded them in the car, brought them home, and of course I called Phill and said, well, help, what do I do with these? So we unloaded them, put them inside and dusted them off and had a bit of a look-see, and let's have a little look-see at what we bought. So what you can see here is a 7727 local unit. It's a 100 watt single sideband radio. It's a crystal controlled radio. Pretty simple, straightforward.
10 channel.
Well, yes, up to 10 channels. Controls are on the front, speakers on the front. All you do is plug the volts in the back, the antenna in the back and the microphone on the side, and away you go. So that's pretty good. But all these other radios, what the hell are they? So a 7727 TB, a lot of them. Now what I didn't realise was that they needed a front remote control. So these were intended to be down the box was to be down the back of the radio, or back of the car, truck, whatever, and the local head was at the front. And there was a big long cable going between the two. Well, of course, I didn't get the remote unit, and furthermore, much digging, and those Jones-like plugs are like rocknose teeth. So, makes it interesting. But it's a 9x4 by, well, -1 because there's a keying plug in one corner. And that was it. Now, there are only a couple of cases with all these radios, so I've got a couple of cases. And did I say that most of these radios were faulty? I might just digress a little. The guy that was a deceased estate, the fellow was an interesting character, must have been an interesting character. It seems like he was an electrician, probably a railways electrician. He was a ham, I forget his call sign, it was a Y, 3-letter Y call. He was a Land Rover enthusiast. There were Land Rover engines on pallets, there were Land Rovers, there were Discoveries, there was all sorts of stuff, and there was a lot of radio gear. So there we go. So I thought, well, I might have a play with this, and maybe if Glenn YY can play with a DDS, so can I. So I hopped on the Google machine, and I then started to understand what the 7727 and the 7727 TB versions are all about. So they're 100-watt radios, they're crystal controlled, and you can set them up to operate between 2 and 18 megahertz. So what will I do with these things? I thought about the DDS as a prospect, and I found that I wasn't the first to start looking at this. Others had done it before. VK3FUR, now Michaela, I think we've seen on a previous presentation with Mark 5 QI on the balloon tracking. There's a YouTube, but it doesn't really tell you much, except that there's a process, but you don't see a finished product, so it's a bit hard to know. VK3JME and VK3ZYZ have played with Arduinos doing this. 5TM's put a PIC in it. ZL2PD's done a Sugar Cube Plus. Now that's a little, I think it's Arduino based, a little box that he builds that he uses to do this sort of thing. ZL1BPU has quite an interesting web page on the 7727, and also he's turned one into a 100-watt linear amplifier. I'll talk a little bit, I've got a little bit about that very later on. And 5DJ plays around with a PIC, and he puts together a good discussion and conversion detail. So that's that little piece. The next page, if I've got the right one, yeah. So let's turn these boxes over and have a little look inside. The common thing between, you'll see them, they're there here on the desk. There's a top board, it's a receiver and the RF board. It's common to both, and in fact in that view it's very hard to tell whether that's a TB or a local or a remote unit. Not that it matters much, but anyway, that's a 10-channel box, as you can see. Or it's set up for 10 sets of coils, not 10 sets of crystals. But you can see where they are lined up across there. So looking around these radios, they're an 1850 kC local oscillator, and the audio and power regulator's up in the top right-hand corner. And there's a crystal filter there, upper sideband crystal filter. This one's got a receive mute board on the left-hand, down the left-hand side of it, in beside the crystal filter, which is the shiny box. And some have a cell call and emergency call facilities built in, or boards to provide that facility, but I pulled them out, thinking that they weren't really very necessary. If we flip the radio over and look at the underside, then you start to see the difference between the two. The PA boards, which in this particular case is the board down the bottom, they're the same, but they have different filter arrangements. In this one you can see that this is a local unit, and the filter board is up there on the top right-hand corner. It's a pair of MRF 421s driven by a pair of MRF 220s, and they're the 421s are 100-watt transistors. And the local unit has a channel selector rotary switch which selects the required filters and crystals, and you can see that sort of coming vertically down from the top right-ish corner. Okay, so if we flip over a 7727 TB, we see the same PA boards, but a different filter arrangement. But once again, a pair of MRF 421s driven by MRF 220s. The interesting thing here is that the filter arrangement, obviously there's no rotary switch, so the switching from the remote head actually selects one of the 5 relays that you can see there, and you can strap each of those 5 relays segment 2 meg to 18 meg in each little component, and they're strapped to switch that relay. So when you select a channel that's within whatever, it selects that relay on, and the filter's there and all ready to go. Whereas in the 7727, it's actually hardwired off the rotary switch. So strap the channel and the filter, and away you go, and you've got a bulletproof PA, which will give you 100 watts from about half a watt. And we can talk more about that a little later. So the TB. Now you can see the TB is the radio in the middle over here. That's it in its raw state. You can see the big Jones plug. Now how good is that? Oh yeah, that's all right, that's good. So this is how I fired it up. I figured that the DDS was not going to be a tidy modification to put in the local head radio. Where am I going to put the display and make it neat and stick a hickey on the top or something? So I decided I'd have to take the TB by the horns, and I could probably pull out that Jones plug and start mounting things there in a blank canvas. So that was my concept. So, but it gets a bit messy when you're playing around with a Jones plug that you can't buy the plug to fit the socket. So I managed to put a bit of solder on some wires and squash it flat and shove it in, and it seemed to stay there okay. So what you can see there is that all the controls to the remote head are driven off that 35-pin socket, and each of the switchable functions, such as the channel or the mute or whatever, is used. They use a 1N914, just pull it to ground, and that's how you select those various functions. But in this particular case, here's me hooking it up in the shed. The blue pair are the wires off to the speaker. The 3 yellow wires go off to the volume control. The red ones are short to the volts, and you can see a bit of a bird's nest of diodes sticking up on the right-hand side there, where I've selected channels and whatever else I was doing there, I can't remember. But so little things like if you want to do a hit TX tune, you just 1N914 and pull it to 0 volts and it'll select it okay. So you don't need a whole lot of HP whiz-bang gear here, and you can see I don't have it, and what's more, I don't have room for it. But anyway, that's what I use. So if you've just got the basics, a multimeter, a SIG-gen, I had a little 2-tone generator board that I'd got from somebody, I can't remember, I bought it as kit and built it. Just some sort of power meter to know what you're doing in terms of output. Dummy load, of course, and a crow is useful when you find that half these radios don't work. So that was all I had. That was just my setup there. So the DDS, what do we know about DDS? Well, I'd selected a couple of working 7727s and thought, well, let's have a play. So we know that a crystal will resonate at a specific frequency when a voltage is applied. So let's have a think about this DDS thing. And if you have a look at Wikipedia, it'll tell you that direct digital synthesis, DDS, is a method employed by frequency synthesizers, excuse me reading this because I don't know it, used for creating an arbitrary waveform from a single fixed frequency reference clock. DDS is used in applications such as signal generation, local oscillators and local oscillators in communication systems. Sounds like what we need. So this means basically that we should be able to just pull that crystal out, stick a DDS module in where the crystal was, and providing the circuit around is sufficiently wide, or at least can follow the DDS, then you've got a variable frequency VFO receiver and transmitter. Simple as that on the surface. So my project was to simply a modular solution, purchase a module, stick it in, get it going without too much deep and meaningful understanding. And for those that are interested in what a DDS really is other than a wiki. Phil will give us something on that a little later. So I hopped on eBay, and I'm missing a page. No, you saw the page earlier.
Yep.
So there I bought it for, I forget, $40 or something, $36 I think, remember? But anyway, it's made in India. They're not hard to find. Probably the biggest problem that I had when you flip it over is where do you get the plugs to go in all those holes? Anyway, I managed to jerry-rig it. And this DDS, of course, runs on 9 volts DC, and of course the radio's got 12 volts kicking around inside it. You know, a bit of fun trying to sort it all out. The DDS module's got a regulator in it, and that runs pretty hot at 12 volts. So I dug out a 7809 and used that to knock the 12 down a bit. And oh yeah, that was another trap. The DDS module earth is 0 volts, and earth in the Codan is earth. 0 volts is a different kettle of fish, so it had to be isolated, which if you have a look at that one, you'll see what I've done. I just used little nylon spaces or plastic spaces. So that's a trap for young players that I learnt early in the piece, fortunately. So yeah, that's the module from the back. So now we start with the modification, and on the top right hand side you can see the 3 coils associated with 3 channels. You can see a crystal just over to the left hand side, which is in channel 2. That's on 8022, and I left that there intentionally because it gave me a reference so that I could play around with the DDS in channel 1 and go back to channel 2 and just say, oh okay, well that's working, and how I could sort out things. So the coil's up on the top right hand side. If you read the service manual, which I don't know whether I said, but it is available online, so you can set these radios up for 80, 40, 30, 20, no problem at all. Although the coils vary. These the 6 little coils up on the top, there are varieties, but they can be modified, although if you can get them out in one piece, you've done well. But they can be modified for the different bands. But I thought, well, obviously the coils that I've got are set perfectly for 40 metres, so I'll use 40 metres. So just simply a coax cable, which you can just see there diving out to the bottom right. A little bit of coax cable with a 0.1 capacitor to block the DC volts that was once pushing the crystal, and so I just put it in channel 1 as I've said before and left the 8022 in channel 2. So the Codan is designed around crystals, and the RF coils are tuned specifically to a channel that's been selected by the crystal. So they're fairly narrow bandwidth, and as mentioned earlier, others have added their own version of VFO to their Codan, but it seems that, and talking with Phil, nobody's bothered to tune the RF stage so that it follows the DDS. So we'll get to a little bit more on that now. So underneath those 6 coils that you saw in the previous page are 6 capacitors. And those capacitors provide a tuned circuit around the crystal frequency, and you select the capacitor and adjust the inductance to meet that particular channel. So if we want to have a variable frequency crystal effectively, then you need to be able to change that capacitor. So now the fun starts. So the service manual gives you details of the appropriate capacitor for certain frequencies. And chatting with Phil, he said, oh, well, why don't we just use VariCap? I thought, oh, well, that sounds good. What's a VariCap? So we teach that in the advanced classes, and that's about the closest I've ever been to a VariCap knowingly. But we decided that we'd have a bit of a play. And my thinking was that if I can just vary the voltage to the varicap diode, or diodes, then that'll just pull it along. So why don't I do, I've got an FT102 at home, and I know other early Yaesus do the same. So you just select the frequency that you want to operate at and adjust pre-tune for maximum noise, and you're there. So I thought, righto, that's what I'll do. So I'll bring a pot out to the front of the radio, I'll call it pre-tune, adjust the voltage to the varicap diodes, and that should be where I want to be. And it pretty much is, and you'll see that I've done that over here. So a pair of diodes, once again I phoned a friend and he came up with a suggestion at that stage of a BB112 diode, and that's what I've used. And the actual circuit that we used, Phill will talk about that later because he knows more about it than me. So in the next page, you can, just down the bottom, you can see 4 little two-legged devices sticking out. So that's the 4 varicap diodes. The manual says that for 40 metres, about 50 puff is what we need. And I'd proven that by doing that to one which had a crystal in it that was near enough, and I knew that that was about right. So a BB112 delivers 17 to 520 puff from between 8 and 1 volt. So I found that about 7.5 volts was the sweet spot for 40 metres, about 7.1. And I found that half a volt either side of that, you'd lose it altogether. You'd lose the peak of sound, of noise. So that's what I did. 4 varicap diodes and some volts fed off a 10k pot, and that's what it is. So the radio closest to me is the finished product. So you can see the controls there, on-off volume on the left, the original mute switch, which is the mute control 1N914 to to 0 volts, provides the mute control. The channel select DDS or 8022 is once again a diode to 0 volts. And you'll see that that module has got 6 push buttons across the bottom that are part of the actual module. They've got a whole lot of functions in them to program the module. Things like the IF offset, 1850 KC.
1650, yeah.
Oh, 16.
Sorry.
I haven't even written it, so
Yeah.
thank you. You can program the tuning range that you want to use it in, whether you want to use upper or lower sideband, a RIT control, and so on. So this is where the upper and lower sideband comes in. You can tell the DDS whether you want to be upper or lower. So that's pretty helpful. And a pre-tuned pot, a module, and a device for tuning the DDS. So that's something you need to go out and buy. Some power and an antenna. So that's pretty much the story of what I did and how I got there. I can't say that I would have been able to do it as well as I did without Phil's help, but thank you very much, Phill. The learning, well, it was easy and cheap to construct a 100 watt SSB transceiver for 40 metres. If you want to have a go, do your research. You'll find there's plenty of info, including the 7727 manuals, the TB and the local unit. And removing that big socket means you must label everything because there's a lot of wires on it. And this is the first practical experience I've had that I know of with a varicap diode. And what it means is that I've saved a couple of old Codans from e-waste, and it's provided me with hours of fun doing what I most enjoy, was putting things together and trying to make them work. That's what I enjoy in amateur radio. And Phill and I discovered that you can actually collaborate on Microsoft 365, because in the early days, Phill said, well, how are we going to put this together, this PowerPoint? I said, oh, well, we'll put a date on it and send it over to them. And then my daughter told me, we collaborate on that all the time, Dad, why don't you do that? So we did, and that worked out really well. So just before I wrap up, I just did put in a little page here on the Z01 BPU linear amplifier. Now you remember that I showed you an underside picture of these radios with the linear amplifier. So Murray Z01 BPU details this in his website, and it's the 7727 PA is completely self-contained. It consists of a circuit board on some heavy plate, so it's well heatsink material, and the design lends itself readily for readaptation. The PA section consists of a controlled AGC amp, Class A amp, Class AB push-pull 5-watt driver, and that operates Class AB push-pull final stage with a 100-watt PEP capability. So it also measures SWR and protection circuitry, because you can imagine these things were taken to the bush with a bit of wire chucked over a tree, so you know, they needed to be pretty robust. So with the whole amplifier as a broadband design, it's capable of reasonable output from about 200 kHz to at least 19 meg, they say. Well, that's what Murray says. And yeah, so that's something that somebody might like to have a play with. And it's a great project for a headless 7727 TB, because it's all there and you've even got a case and the heatsink on the back of it. So it's ready to rock and roll if we just... So there it is again. I don't need to repeat what I've said before, but the amplifier is just down the bottom, and you can leave the filter boards there as well if you're keen. So feed it with 12 volts, feed it with your Yaesu whatever, and away you go. So that's my little story. I'll put it over to Phil and let him tell his story.
All right. Well, Dave and I did a lot of arm wrestling to see who was going to try and explain to you what direct digital synthesis is and how it works. And I won the fight, but or did I lose it? I'm not sure.
He knows what he's talking about.
Direct digital synthesis is not magic, in spite of what Arthur C. Clarke says, that any sufficiently advanced technology is indistinguishable from magic. This thing's not magic. You step us through a bit, Dave.
What you're doing. Oh, okay. Sorry.
It's all right. It's not an oscillator. It doesn't oscillate. It's not a phase lock loop. It synthesises a sine wave at the frequency you want from mathematical principles, basically. If I was to give you a sheet of paper, graph paper and a calculator, and say calculate y equals sine x for values up to 360 degrees every 5 degrees, you'd end up with a sine wave that's... I should do this for the zoomers to see. I think the zoomers can see that, can they, or can't they? I'm not sure.
No, I don't. They might.
But basically, you plot your points on your graph for 360 degrees, and you store that in a table, so that basically that's the table that's going to create a sine wave for you as we move on. So the main component in that is a digital to analog converter. Yep, we can go on to the next. This is a digital to analog converter block diagram. It's a 6-bit digital to analog converter, so there's 6 input leads, and it's set up for set up for you load a binary number into it. You could have a row of switches and you could switch them on and off. And the best way to understand a digital to analog converter is that it's a computer-controlled voltage divider. You give it 5 volts as its reference, and the number that you feed into it selects what stage you want to divide down. 6 binary bits gives you 2, 4, 8, 16, 32, 64 possible combinations. Divide 5 volts by 64 and you get about 39 or 40 millivolts. So you'll have a step every 39 or 40 millivolts, depending on what you throw at it. So you take the table that we created with our calculator and our sine table, and someone in the real thing has done a lot more careful mathematics than you and I could do, and stored that table. And every time the clock steps on one, it reads the next location out of the table and steps it through. Now you'll see the sine wave there is pretty blocky. That's probably mostly because it's a 6-bit digital to analog converter there. The more bits, the finer the steps, and you'll get a slightly smoother waveform. We go on to a bit more of a complete circuit of a digital synthesizer. You've got that D to A converter on the end of it. You've got your analog to sine conversion table algorithm in the middle. You've got a phase accumulator and a clock reference. Phase accumulator is just a divider, basically. You've got the clock, which in the case of the one that Dave and I are using is 125 megahertz. And you simply give it a number and say, I want you to give me this fraction of 125 megahertz out as my clock to step everything through the D to A converter. So if it was you wanted 12.5 megs out, you'll say divide by 10, and it will then start to clock this very same table every time. It'll be giving you the same sine wave out and producing you a nice sine wave. If it's not perfectly clean by that stage, you feed it into a little low-pass filter, and suddenly you've got a nice clean sine wave at the frequency you want, out of nothing, basically. It's just generated a sine wave. So that's pretty much it. That's the analog devices chip that we're using. It's using a 10-bit digital to analog converter, so you lot finer steps. You can load a signal into it from parallel lines, your 10 parallel lines, or you can do it serially. Mine uses it serially because it's easier. You're not constantly changing frequencies rapidly, so you can take the time to load the 40 bits or something that it requires to load that single bit into the thing. It's got, you give it the clock reference on the clock reference in. It comes out as an analog. This has a comparator here which allows you to turn it back into a square wave. And in fact, when I show you the photo of the little DDS module that I'm using, you'll see there's a pot on there which allows you to set the duty cycle of that square wave by basically setting the level. It comes in on the other line there. The analog comes out, goes back in again, and you set a pot on that line to set the threshold. So I hope that sort of, in a nutshell, explains what a DDS synthesizer is, so we're not talking mumbo jumbo. I decided that I didn't know enough about the device that Dave bought. Could it even allow me to select a 1650 IF offset? What else can you do with it? How much control do you have over it? So I thought, no, I want something that I can make it do what I want to do. And so I grabbed this little design by this bloke, John Olsen in the UK. He doesn't quote a call sign on it, so I figure he's a civilian. And he had this little project in a little box, make a little sine wave generator. And so it's very simple. It uses the chip out of the Arduino Uno board, uses the little DDS module over to the side here. little TDF display, a couple of rotary encoders, and all you need to run the AT Mega chip on its own is 2 capacitors, a crystal and a pull-up resistor. So you can take that chip off the Arduino board and run it separately. Everything behaves the same as it would in the Arduino Uno board, except you've got it on the board. John Olsen gives you a circuit board layout that you can build your own printed circuit board to build up his little module. I decided that I'd just use a bit of Vero board and make it up that way. You can actually buy the Arduino Uno chip, the AT Mega device from JCar. It comes pre-boot loaded. These things, when you get them raw from the factory, you need to teach them that they're an Arduino. So you go through this boot loading process that just puts enough smarts in them to talk to you, and when you try and load a program into the Arduino, you've got to boot load it first. That's the little DDS module, and it's got that analog devices chip, the AD9850 chip. That's the little pot that just uses for the square wave out, a crystal, and a bunch of components down the side. Here is the filter. On my board, there's quite enough output from this board to drive the oscillator circuit on your Codan radios, but I wanted to try feeding it into a valve radio, a little Lafayette radio that I had there, and there wasn't quite enough drive, so I added a little op-amp circuit there and just give it a bit more drive, but that was just an experiment. All right, let's go. So I said, righto, this sounds good, I want to do this and I want to make it work. I decided that you can't buy half the components you want to buy these days unless you go to surface mount. So I said, I've got to bite the bullet, I've got to learn to surface mount solder, surface mount everything else. So I sat down and worked out a block diagram, and this is still basically the same circuit from John Olsen. Uses the AT Mega CPU, 16 meg crystal, a little DDS module, the interface, the display, the rotary encoders, etc. I added to it a bit more EEPROM memory. The Arduino's got a fair bit of EEPROM memory that you can store things, but I thought if it's going to be a receiver, you're probably going to want to remember the last frequency you tuned to, and if I need a table to look up to do the to tune the VariCap diodes, I'll store it in some EEPROM, and a little digital to analog converter chip there that is going to drive the VariCap diodes. So I wasn't happy with Dave's idea of just using a pot. I wanted to make the, as the processor tuned the DDS module, it would output a signal to the little D to A converter chip there, and vary that voltage to the VariCap diodes, hopefully. So this is what I ended up with, my own little printed circuit board. I laid out a second AT Mega chip on there because I thought I needed more expansion. I gave myself a bunch more connectors there. It's the same display, running the same software. I added a couple of push button switches. The rotary encoders are still there. And this is the little digital to analog converter chip there, so blinking small. And that's basically what I came up with, which then decided that the chips that Dave, the VariCap diodes that Dave had were originally designed to replace an air variable capacitor that you'd take out of your normal broadcast radio, and it's quite a lot of capacitance. It's at least 40 to 450 or 500 picofarads, and you need to, with a VK3RU diode, is, as Dave said, we teach this to the advanced classes, that the depletion layer, the more reverse polarity you put on it, the further it effectively pushes apart the two sides of the capacitor, and the more volts, the lower the capacitance. So to lower it, Dave has had to run his at about 5 or 7 volts, 7.5. I wanted to run it off the digital to analog converter that only had a 5 volt output. So I said, well, we don't need such a big diode, and I found this BB210 diode, which has 27 to 95 picofarads, which gets us into the area we wanted to be. Tiny little surface mount blob. The blob of solder that it's soldering it to the board is bigger than the chip itself. But doing some testing, it showed that about 1 millivolt step tuned the front end about 1 kc, so it's fairly good. I'll have about, I think that's wrong, there's about 1.2 millivolts per step. So we will be able to do it. I don't have a working one yet. I've been working on this for 6 months or 9 months or however long it's taken us, Dave, but working out of Wodonga, it's a lot harder to get components and things that you need, so it's taken a while, but moving right along. Just Dave didn't go into a lot of detail about the front end of the Codan radio. The front end transistor here, this circuit diagram is a bit deceptive. There's a coil there and a coil there. That's the two front end coils you see for each channel. And the dotted line down here is just saying that there's effectively up to 10 of these circuits, 10 of the coils. Each coil's got a pair of diodes to steer it. And the same device works for transmit and receive. So the coils transmit coils as well as receive coils. And we had to put 2 diodes in series because basically both ends of the coil are grounded. So the only way you could do it is to feed into 2 things. That's what we've got at the moment. We've got the VK3RU diodes. One of the most essential tools for working in surface mount is a microscope. I had to buy this microscope to be able to read the find pin 1 on that little D to A converter chip to check my soldering on the Arduino chips. They are, you know, an old bloke like me. I've got a Maggie lamp to work with, and I do most of my soldering under the Maggie lamp. It's a bit tight under the microscope, but you really need things like that to work when you're doing that. Basically, the conclusions are, what have I learnt? A, that surface mount comparators are very small. Every time you try and buy something, I was trying to buy 125 meg crystals that run off 5 volts. No, they don't make those anymore. Everything's 3.3 volts. So I would have had to change the D to A converter chip will run off 3.3 volts. The Arduino will run off 3.3 volts. And I could have changed the whole thing, but nah, too hard. So I ended up with, say, going back to the using the DDS module. I bought when I tried to buy the DDS chip from either Digitech or Mouser Electronics, $57 for this blinking little chip. The crystal, which I couldn't buy, was another problem. However, this whole DDS module was $13.50 at AliExpress. So I decided for the third prototype of this board that I just stick the module on there and not try and be smart. I tried to the original theory was that if I laid out the chip and the board myself, I might want to change the filter and change the frequency of the filter and the cutoff, and no, just buy the chip and use it. So I used this KiCad. You see the spelling KiCad. You'd think it's KiCad, but most of the tutorials and everything seem to call it KiCad, so I'll call it KiCad for now. It's not bad. It does a reasonable job, but it's not perfect. You get to a point where it just says, no, I can't find that last possible path through the board and up the other side to do it, and you have to do it manually. I also found there's absolutely no way that Australian PCB manufacturers can compete with China. This little board itself was the first one I made, $2.50 US in China, $15 postage from Australia Post, 15 days delivery from China, 3 days manufacturing time. You send them the files from your KiCad, and 3 days later they'll send you a photo of your finished boards that they're now posting to you by Australia Post, and be back in 15 days. So I would love to buy Australian, and I always try to, but what can you do? So learnt you need a big Maggie lamp and a microscope. What else did we learn, Dave?
Oh, what else did we learn? I don't know.
It's been a great experience, and I'd recommend anyone to give it a try. You're learning all the time. You're learning to use the CAD software to design the circuits. You're using the whole thing, and basically that's my story. And do you have any questions for Dave or myself? Yes.
Phil, had you had any surface mount soldering experience before you commenced this project? And how did you achieve it? What was your soldering?
Very little, very little. When I was in my own business, we were doing a lot of repairs of old Tate 2010 radios, which had a little subtone board plugged into the top, and that little socket would tend to break connections. And we talked to some of the people that were selling soldering irons and stuff like that and said, how do we solder these things? And they said, look, we'll send out a guy and he'll do a little quick course on surface mount soldering, and did something that I would never have thought to do, and that is he's got a soldering iron which is about a 2mm tip with a cup in the middle of it, put a little bit of solder on it and just blob it down the row. And you'd think that you'd end up with solder from one pin to the next, but with plenty of flux on it, you can just draw that row of solder down there. So that was the limit of my experience of surface mount soldering. I've since then done, I bought at the same time from this guy, I bought a desoldering, a hot air gun, so I can desolder components and lift them off and do that. But I didn't have a lot of experience, and I'm learning all the time. So that's the story. Any other questions? And by the way, I have been playing recently with a bit of Barrett stuff, but I did go to Adelaide to be trained on the Codan 6924 and the 6801 in 1970. And if you don't know Codan model numbers, the first 2 digits are the year of manufacture, basically, or the year of design. So these are 77 27s. They were first put on the market in 1977.
Those three have a date stamped 1981,
Yeah.
as it turns out.
And to say, and if you want any help with a Barrett antenna tuning unit, I'm your man. I've been through 3 or 4 of these things that you open them up and they're full of rusty water and mud and everything like that, and you clean them all out and get them going. So that's the story.
Dave, just a quick question. What's
Yep.
that button? You got 40 metres on the top of a switch, and what was the other switch direction?
8022.
8022.
So it's got a crystal in there for 8022.
Yeah.
So that switch actually takes you to channel 2, which is 8022. So I left that there just as a reference, so I could go back and compare and check. If I took that, I'm on my own with the DDS. I've just learnt something too. I don't know whether you noticed, but my computer said you need to plug in because you're running out of power, your battery's running low. I thought, hang on, it was plugged in. And it was plugged in, but guess what it was plugged in? Anyway, I've got a stack of these things, so if anybody wants to have a play, I've got a heap of them. Have a look and ask questions. So, yeah,
Okay.
Phil's taken it one way, I'm taking it the other.
All right, well, thank you very much, gentlemen. Just ask you to show your appreciation of our friends coming down and giving us a very good talk tonight.
Thank
so
you.
thank you very much.
Thank you very much.
And Phil, seeing you've travelled such a long way and made the effort tonight, I'd like to present you with a small token
Thank you very much indeed.
from the club. A nice little banner. And David, for appearances, we'll give you one as well.
I haven't got a new one, I must say, so thanks.
A new one. Okay.
Thank you.
Well, thank you very much once again, gents. It's been most enjoyable. For those that want to learn a little bit more about surface mount, we have a Jack and Peter coming up in the new year on reflow and ovens and the like. So we can look forward to that one in the future. So, all right, that ends this evening. Please enjoy a cup of tea, a chat, a biscuit, and come and have a look at the lovely work that's been undertaken by these gents. Thanks once and all.
No, thank you.